In this video, you will learn about solving systems of linear inequalities. First, let's review the steps to graph a set of linear inequalities. First, you need to solve to get y by itself and graph the boundary line and shade the appropriate regions. Now, if it's a greater than or equal to or less than or equal to, you're going to shade a solid line. And if it's greater than or less than, it would be a dashed line. And if you have a greater than or equal to or greater than symbol, you're going to shade above. And if you have a less than or equal to symbol, you would shade below. The solution set is the part of the graph that is the overlapping area. And every point in the shaded area has to satisfy both inequalities. And we say in this case that a system of linear inequalities has a solution set, rather than just having one point that is the solution.
As a reminder, it's very important that we remember how we determine our different types of lines. If we have a situation where it's just greater than or less than, use a dashed line, versus if it's greater than or equal to, use a solid line. And then also, if it's greater than, we would shade above, versus when it's less than, and it looks like that tilted L, you shade below.
In our first example, we're given the inequalities y is greater than or equal to negative 2x plus 4, and y is less than or equal to x minus 4. If I want to graph from this, because it's in mx plus b form already, m, which is my slope, is negative 2 over 1, and b is 4. So my y-intercept is at 4, so I can plot my point, and my slope is negative 2 over 1. So I would go down 2 and over 1. Now, since it is a greater than or equal to symbol, it's going to be a solid line. So I can use this pen to draw in my solid line. And since it's greater than, I'm going to shade above. So I can shade the area above the line. For the next one, I know that my slope is 1, which is really 1 over 1, and my y-intercept is negative 4. So I can plot my point at negative 4 and go up 1 and over 1. Now, since it is less than or equal to, it's going to be a solid line. So I can draw my green solid line. And since it's less than, I'm going to shade below. So I'm going to shade the entire area below the line. Now this area that is both green and red is what we would call our solution set. And if you want to make that a darker color to emphasize that, you can do that. So I'm going to add in my yellow to emphasize that this is my solution set, or the overlap of the two.
In this example, we're again going to start by graphing the inequalities. So my inequality of y is greater than negative 5 halves x minus 3 has a slope of negative 5 over 2 and a y-intercept of negative 3. So I can start at negative 3, and since it's negative 5 halves, I'm going to go down 5 and right 2. And I can add in my additional points to help me with my graphing. Now, since it's greater than, it's going to have a dashed line. And also, since it's greater, that means you're going to shade above. So you'll shade this whole side of the graph. For the second example, my slope is 1/2 and my y-intercept is 3. So I can start at 3. And then since my slope is 1/2, that means I'm going to go up 1 and over 2. And I can extend my points across the whole graph to help me with drawing in my line. Now, since it's greater than or equal to, This means it's going to be a solid line. And also, since it's greater, this means you're going to shade above. So I would shade this side of the graph. Now the intersection, which is my solution, is this area right here. In this slide, we're going to cover special cases. Now, each of the inequalities are already graphed, and we're just looking for the solution set. What you will see if you look in this one in the top corner over here, that there's the red is the bottom part, and the blue is the top part, but there isn't an intersection at all. So this means that there is no solution set. If you look at the one in the top right corner over here, you can see that the red is this bottom area and the blue is this whole area. However, we are only looking for where they overlap. So the overlapping region is just this area right here, bordered by this dotted line. And then our last example down below, we see the red is this whole area and the blue is the other area above it. The only intersection is this small part of the graph right here, bordered by these two solid lines. And each of these special cases you'll notice occur when the lines have the same slope and are parallel.